So let us solve one problem so that we get a better understanding of this. So let us solve it. So let us say we have equation. So this looks like a very complicated system of equation. So if you can see that this is obviously not a linear equation, because when you talk about linear equation, there will be coefficients and there will be variables. But if you see, there are transcendental terms like cosine, exponential, then squaring. So obviously this is a system of non-linear equation. Okay, and this is very interesting. Now what you have to do is you have to solve this system of equation using Newton-Raphson method that we have just discussed. So the first thing that you are going to do is you are going to write down the function. So first function is going to be, you are going to take this. So this is going to be your f1. So I just want to tell you, I'll not be writing this x1, x2 and x3 again and again, but just to know that it is function of three variables. So this is going to be your f1, this is going to be your f2 and this is going to be your f3. Okay, so these are the three functions. So the first step is going to be to write it down as functions. Now the second step is to find out the Jacobian. So we all know that your Jacobian for three variable is, and when you talk about your f, it's going to be f1, f2 and f3. That is this. I'm skipping writing x1, x2 and x3 in bracket, so I hope you understand. Okay, so I think the very first step is now to find out the derivative and assemble the Jacobian. So if you take the derivative of f1 with respect to x1, if you take the derivative, so since this is a partial derivative, this is going to be constant, this is going to be constant, so derivative comes out to be 3. If you take the derivative of f1 with respect to x2, again this is a partial derivative, this becomes constant, this becomes constant. You just have to take the derivative of this, and derivative of course is minus sign, but again if you see, this is x3. Okay, so the result comes out to be x3 sine x2 into x3, and again if you take the derivative of 1 with respect to x3, the solution comes out to be x2 sine x2 to x3. So similarly you can take derivative for other functions, and if I assemble the matrix, the Jacobian matrix, this is going to be, so this is your Jacobian. So we have to solve this problem. Now obviously this problem I didn't write down the question here, so this was the system of equation, and the question says solve this problem using Newton-Raphson method. Okay, for 2 iterations. So obviously you're going to do it for more than 2 iterations, but I'm just doing it for 2 iterations so that I keep it simple and you understand what I'm trying to explain. Okay, and also in the problem they have given us the initial value. So the initial value of x is 0.1, 0.1 minus 0. So this is the initial value. So let us start with the first iteration. So according to the first iteration, what you're going to do is you're going to write down x1, x2, x3. So this is your first iteration. Then you're going to take the value of x1, x2, x3 from previous iteration but since this is first iteration, previous to that is going to be your 0th iteration, that is your initial value. So that is going to be 0.1, 0.1 minus 0.1. Okay, now what you're going to do here is you're going to find out the Jacobian, okay, by substituting the values, the initial values. That means you're going to substitute this and this values here in this Jacobian. So this is going to be 0.1, this is going to be 3, this is going to be minus 0.1 into sine of 0.1 into 0.1, x2 is going to be 0.1 sine 0.1 into minus 0.1 and so on. So you have to substitute the value and find out the value. So if you do that, you will find out the Jacobian matrix for the first iteration comes out to be, and you have to find out the inverse. Please understand this. So you have to find out the inverse of this, and then you are going to find out this. Okay, again what you are going to do is, if you want I can write down this as well. So this is going to be so you'll just substitute the value of from the previous iteration. Okay, so that is the value of x1, x2 and x3 from the previous iteration. That means the initial values, that is 0.1, 0.1, 0.1, 0.1 and minus 0.1. So if you do that, you will find out the value that you are getting is minus 1.199 minus 2.269 8.462. So obviously you cannot do this step by hand, you have to use your calculator. So when you use a calculator and when you find out the product, you will find out that this value, that is the product of the inverse into this, comes out to be a vector whose values is minus 0.399, 0.0805, 0.4215, and then you have to subtract this from the value 0.1, 0.1 minus 0.1, and that is going to be your value of x1, x2, x3 for the first iteration, which comes out to be, if you do that, comes out to be 0.5, 0.0195 minus 0.5215. So this is your first iteration. Now let us move on to the second iteration. So for second iteration, x1, x2, x3 for second iteration is going to be, now you are going to use the value of the iteration, that is these values 0.5, 0.0195, 0.5215. okay, and you are going to substitute these values in the Jacobian matrix, that is this matrix, and then you are going to find out the value. And if you do that, you will find out the value comes out to be 3, 5.3 into 10 raised to minus 3, minus 1 into 10 raised to minus 4, 1, minus 19.35, and you have to take the inverse of this. Please understand this. To take the inverse of the Jacobian, and this comes out to be, again substitute this value, this value, this value in this equation. So comes out to be So again, if you solve this, do the multiplication, this comes out to be minus 1 into 10 raised to minus 5, 0.0179, and 2 into 10 raised to minus 3, that you have to subtract it from the initial value, and that is going to be the value of x1, x2 and x3 for the second iteration. So if you do so, this comes out to be 0.5, 0.0016, 0.5235. So this is the value of x1, x2 and x3 after second iteration, and this is your Newton-Raphson method. Okay, it looks complicated, but if you just pay attention and if you just focus, you'll realize that it's not that complicated. It's very simple, and you have to solve this equation in real life. You'll be solving this equation using your softwares. Okay, you'll develop a code and then you can solve it, because once number of equation increases, then it becomes very difficult to do it by hand.